Welcome back, guys. DGS, happy Friday, 4:05 Monday. Instead of the DGS, you're going to be hearing Game 6 and Game 7 of the 2011 World Series, and that should be a bunch of fun. George Rosenthal is our guest from ThrottleNet. Y'all know him by now. Good to see you. How
Good
are
to
you?
see you. Thanks for having me in. Appreciate
Fun
it.
sharing the game the other day?
Yeah, that was a lot of fun. That was great. Walk-off home run.
Yeah.
It was great.
Yeah. Okay, so let's talk some weird AI stuff first.
Sure.
And you and I kind of talked about this at the game, that I saw something that ChatGPT usage has dropped.
Yes.
And the author was supposing that humans are already kind of tiring of AI. Do you think that that's true?
So I don't personally think, what I think is that the opposite competition is now picking up. So Bard is now increased in traffic because they're tied live to the internet. So I think what happened is that the novelty of the ChatGPT thing kind of took off, and then the word got out that GPT is not tied to the internet, and the last data that is inside that system is September of 2021. So I think AI has taken off in a way that people are using it more than ever. There's a lot of competition. When ChatGPT first came out, OpenAI was the only store on the block you could go get. And everybody was fascinated, and you couldn't get on half the time because the servers were overloaded. Now there's AI everywhere in all sorts of different forms. And I think that's a true sign of what's to come, is you're going to have more and more AI spreading out and a lot more choices, and which is great because then you're going to end up with competition, but also different things different AIs do different things. You're like, one does pictures, one does audio video, one is going to be a structural way of looking at language models, one's going to be predictive models based on data. So it's going to be fascinating to see, but it's way AI isn't just one thing that people should think of as just one solid thing. Like it's everywhere. It will form into everything we do. And I know we've talked about that a couple times, but people really need to start thinking about this in everything you do in life.
So AI is more like electricity.
Yes. Yes. It's a great example. It's involved in every single thing you touch and do throughout your entire day. From the time you go to sleep, and even when you're sleeping, you have a timer that's going to wake you up.
I can do that and still make the McNutt joke. So that's why I'm the best.
He's multifaceted.
Okay, and we also talked about this. So I also read somewhere that at some point, and I'm interested in when that point is, something like 90% of the internet content will be AI generated and therefore sort of useless.
Yes.
Explain that concept and how quickly that might happen.
Well, just put it into little pieces. Right now, there are blogs that are being created on people's companies' websites that weren't written by a human. So that's just the beginning tip of the spear. You're talking just to have blogs out there of articles that people are now reading and taking it verbatim were written by a machine. And imagine that going everywhere now. So now then you blend that into news and you say, okay, the news article that I'm going to read started off as 5 bullet points and then AI wrote the rest. So it may be humans putting in the 5 bullet points of what happened in that news story, but the actual paragraphs were written by AI.
I'm not even sure what I'm asking with this, but is AI generating anything on its own, or does a human have to push buttons to make AI generate something?
AI only works right now as a human inputs a command or something like that.
What about that thing that AI recently posted a picture of, like the corner of a room or something? You know, on this one?
Yeah. I saw a little bit of it, but it was still person generated.
Okay.
Yes, AI is not at the point where it's self-doing anything. Now, one of the things I get questioned about, since I've been in with you guys a lot, I get questions out in the world about, well, when does it start to do that? And that's going to be quantum computing. And then every time I say that, the folks out there are going, hey, well, tell me more about quantum computing. So I think if I could take 2 minutes, I think it'd be really neat to share some ideas and concepts of how quantum computers really work. So quantum computer reaches, your basic laptop, you'll hear the fan kick on, it gets hot, right? Quantum computers get so hot that they require 15 millikelvin, which is they have to be kept at negative 459 degrees Fahrenheit. That is colder than outer space. That's how hot a quantum computer gets.
And what causes the heat?
So just the amount of power that it's processing.
Okay.
Just the amount of power. So
So that's why your phone gets hot on your lap sometimes.
Correct. Just the amount of transactions that are occurring.
Fascinating.
It has to be kept so cold. So if you get a chance to look at a quantum computer, and for those of you who've never seen one, imagine a pyramid upside down. Okay, so upside down pyramid. So you got a big base at the top, and all the way down to the bottom is a series of tubes, all these little tubes.
Oh, it's like the internet.
Kind of like the internet. But what's weird is...
Sorry.
That's all good. No, but it is. It's a series of tubes. But what's wild is the entire 90% of the top of the upside down pyramid is just refrigeration.
Oh,
That's
man.
all it is. So the bottom portion of the computer is just the processing part of the computer, and the rest of it is just the refrigerator. It takes an entire room full of refrigeration just to keep this thing at negative 459 degrees.
So someday, people like you will tell that story the same way that people tell the story of the first computer took up an entire
mainframe. That's
giant
right.
room.
The giant mainframe, and it took a whole room of computers. That's exactly what this is now. IBM has the fastest quantum computer in the world, and it takes up a giant room, but 99% of the room is refrigeration of liquid nitrogen just to keep this thing that cold. So, of course, that's going to go down, just like the mainframe went down. But one thing I want to explain to people out there that a normal computer right now has a silicone chip, thousands and thousands of silicone chips, and they're like a transistor. It's either a number 1 or it's a 0. It's literally an off or on type of deal. And, a series of ones and zeros means a certain letter or a color, and that's what you see on your screen today. A quantum computer doesn't work like that. Think of like a wavelength, like a radio wave. And at the top of the wave, you've got a number 1, and at the top or bottom of the wave, you've got a 0. And everything in between, the 1 and the 0 on the way up and on the way down are all increments. Then blend 2 or 3 of those waves together, and it's looking at how the waves interact and making predictive decisions based on how those waves are going to interact. So if you got one wave that's going real slow and one wave that's going real fast, and you bring them together, it's making a prediction on what will happen or what will be the outcome of those two waves coming together. So imagine being in a pond, you take a rock and you throw it in. Then you take another rock and you throw it next to it. And now you've got 2 waves that come together at various speeds based on the size of the rock. Now throw in a third rock, and now you've got 3 waves coming together. The model is just simply looking at how the waves interact with each other at peaks and valleys and so forth, and then makes a prediction on what the next rock will do.
Okay.
So it's
magic.
It's kind of like
because I don't understand anything. You
What
just
does
said.
it do with that?
So it's giving you predictions. So don't think of a quantum computer as like your calculator on your phone where you're doing addition. Like, 1 + 4 is 5. You're not doing that. This is taking tons and tons of data and making predictions on what will happen next. So it's really a predictive, it's all about predicting the next outcome and then what happens with that outcome and what happens with that outcome. So think about putting in strands of proteins to create a new medicine. You're talking about blending in all these different proteins together. Think of those as waves in a pond.
So unlike AI, it's actually thinking.
Correct. But it's not doing so one of the things that's not correct that everybody thinks is that it's not trying all the options.